very quickly, so it's all in one place. In this review section, we're going to quickly rock through all the stuff we know about exponents, okay? But we are going to use variables because that we know that no matter what the base is, it always applies. All these rules apply, yes? So the first thing we're going to review is the basic rules of exponents. X to the y means x times x dot 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 y times. Everybody understands, yes? Don't need to review that. X is the base, y is the exponent. That's all good. Yeah? Yeah. Okay. 2. Negative x to y. What do we know about that construction? Sam?
If the y exponent is even, then
Y is even, so the answer is positive. Y is odd, the answer becomes negative. Cool. All right. What do we know about this construction? Negative x to the y. You just did one. I guess it's you again. So the answer is negative. Everybody is cool with the basic 3 laws, yes? Yeah, yeah? Going once, going twice, going thrice? Yeah, yeah, yeah. We are all driving Volkswagens. Yeah, yeah, yeah. Number 4. Now we get into the actual laws. X to the y. I'm not going to use y anymore. X to the a times x to the b. What's that? A plus b. Number 5. X to the a divided by x to the b. Alicia? A minus b. Number 6. X to the a to the b. Taylor? XA times b. AB. That's the middle level laws. And finally, the top laws. 7. X plus y to the a is what? It's either the sum to the a or x to the a plus y to the a. Right? Jack, be nimble. Yes, you could do that as well. And the other one we had was x to the a over y to the a is xy all to the a. Is everybody good with everything we've done with exponents up till now? Everyone agree? Okay. What have you noticed about every single exponent that we have done? Notice I said exponent, not base. What have you noticed about every single exponent we have done since the first day we started talking about exponents? Jack? No, because we have done plenty of cubes. Not quite. Michael? What do you mean by simple? Now we're talking. They've all been whole numbers, yeah? One thing that's been noticed. What else?
They've all been positive.
They've all been positive. Okay? Fraction exponents, rational exponents, you will learn in the 10th grade. We will not go into them here. But we will go into exponent law 6, which is actually more than 6 because I've split these up a little. Exponent law 6 is negative exponents. Now, have some of you indeed seen negative exponents before now? Some of you have seen these? Lovely. That's good news for me. Normally, people have never seen these before. They make sense when you think about it. So what would a negative exponent look like? Well, it has a base, 3. It has an exponent. I've got 3, negative 2 right there. We'll do it with letters. It's got a base, x, and it's got a negative exponent. Everybody cool? Jack, is your hand up to... Okay. What? If there were no negative there, what does this mean? X times x. Twice, right? That negative means I'm supposed to multiply x by itself negatively twice. Does that make any sense? Somebody always says, well, then isn't it negative x times negative x? No, because the base is positive x. So it can't be negative x times negative x, can it? You do kind of divide. I'm going to show you what I mean. I'm going to show it to you in 2 ways. First one I'm going to show you is this, with numbers. What is 3 cubed? 27, right? 3 times 3 times 3. What is 3 squared? 9. How did you get from 27 to 9? Divide by 3. You guys have seen this chart already, right? And it stopped at 0, didn't it? Right? Because 3 to the 1 was 3, 3 to the 0 was 1, correct? And what do I do at every step? Divide by 3. Well, you guys are smart kids. What's the next logical exponent? Jack. 3 to the negative 1. No. What am I doing every time? So this would be 1 divided by what? 3. Picking up what I'm putting down?
But isn't that a decimal?
Of course it is. Everybody see that? Now, what would 3 to the negative 2 be? No. 1/3 divided by 3, right? Which is 1/3 divided by 3 becomes 1/3 times, what's the reciprocal here? 1/3. What's 1/3 times 1/3? 1/9. Are you seeing a pattern? What is 3 to the negative 3 going to be? 1/27. 27 is positive 3. 1/27 is negative 3. Does everybody see it? It's not magic. It's actually the complete opposite of magic. It's the only logical thing that makes sense, doesn't it? Yeah. Now, there's another way to prove this, and I'm going to show you that over here in green. It's this. What if I had x squared divided by x to the 4th? Are they the same base? Yes. When I divide, what do I do with exponents? Subtract. So what is the answer? X to the negative 2. What? Screw that, Pooh. That makes no sense. How do I multiply x negatively? So then you have to use your brain. Wait a minute, I got this. X squared is x times x, yes? Divided by x to the 4th. Okay, x times x times x, naughty, times x. Everybody good? What happened here? Gone. What happened here? Gone. What's left? X squared in the denominator, yes? What's up top? No, because 0 divided by anything is 0. This is something. So what has to be there? 1. So x to the negative 2 is the same as 1 over x to the 2. Just like, what's the denominator? Don't write this down. What's the denominator here? 1. Always. Do we write it? No. What's the exponent here? 1. Always. But if I have this, I have to write 1. Because if I don't write it, that's a 0. And what's 0 divided by 7? 0. But that's not what it is. It's quite obviously something. So we have a 1 over it. Is everybody cool? So we'll always start easy. Let's start easily. 3 to the negative 2. Does that make any sense? No. So what does it become? 1 over 3 squared. That's a positive exponent. Why? Negative exponents defy logic, don't they? How can you multiply something by itself a negative amount of times? Right? It doesn't exist. So we can't ever have a negative exponent. If you see a negative exponent, it cannot be there. This is how we fix it. So now I have exponent exponential form, yes? Is it evaluated? No, because evaluated means there's no more exponents. So what does this become? 1/9. Somebody had a hand up over there. What was it? Okay. Now let's look at the second one. Remember, we always start easy. But we must remember, why did I review all the stuff we know about exponents? Because why? Jack? So you wouldn't forget it, because every law still applies. So let's go to this next one. What do I see about that guy that I don't like? Negative. Which negative? Because I see two negatives. Can bases be negative? Yes. Can exponents be negative? No. So Jack, what do you think I do with that? 1 over 3 squared. And what has to be out in front? The negative sign. Everybody got it? The exact same thing as here, but I got a negative out in front. So what's the answer? Negative 1/9. Everybody cool? If you're lying, you're dying. Is everybody cool? Yeah. Okay. Where do you see a negative times a negative? Why did Jazreet think that? Sam? She thought this squared applied to the negative as well, didn't she? Why doesn't it apply to the negative? What's missing here? Jack? What would attach it to the 3? Brackets. Oh, goodness, look at C. Oh my gosh, it's like I knew where I was going with this. Jack, you're on fire today. I should take my tea over and pour it on you. Might set off the alarm again. We'd all have to go outside.
So would it be 1 over negative x squared in brackets? And then I guess you could theoretically say that'd be 1 over y. Well, x times x, I'm saying it would be y.
I see what you're saying. Can I leave it that way? Can I evaluate this? I don't know what x is. This is not evaluable. Yeah. Now, what if I told you this? Now could I evaluate it?
Yes.
So that becomes 1 over negative 4 squared, which would be 1 over positive 16. Everybody cool? Everybody cool? All right. Now, I'm going to write something on the sheet that I haven't taught you yet.
I'm gonna guess.
You're not going to guess because guessing would imply that you don't know anything. You're going to use what you already know to figure it out. Is everybody ready? Find yourself a little bit of space on your sheet that isn't at the bottom. So I'm going to do some other stuff at the bottom. Okay? 3/4 to the -2. No positive exponents and evaluate it. Go. Don't put your hand up. Don't scream anything out. Just write it down. Think about it for a minute and see if you can figure it out. You think you're ready, Sam? Hit me.
Technically, like the negative you ever wanted a little bit, technically flip it. So like 4/3 and then 3 on the square.
Okay. Where? Here? Okay. All right. So you're telling me it's 4/9. That is Sam's guess. Final answer, 4/9. Don't write it down because I haven't said if it's right or not. Does anybody have something different? Jack, be nimble.
I had 9/16.
This is Sam. Jack says 9/16.
I had 3. Well, my final answer was 9/16.
So Jack went 9/16.
I got that by, so I did 3 to the -2 and 4 to the -2.
Mm-hmm.
Since we can have a negative exponent, then I multiplied 4 times 4 and 3 times 10 to get 9/16.
Okay. So I will say Jack is warmer, but not right. Does anybody have a different thing?
I did flip my fraction like Sam did.
Okay.
And, my answer equaled 16/9.
There is the right answer.
I forgot there was rounding there.
Why is Gurpinder right?
She's smart.
No. Michael. You had to remember that since it's in brackets, the exponent goes everywhere. That's what we did yesterday, right? So Jack was right here, and then Jack looked at it and said, I'm not comfortable with negative exponents, but he didn't realize that, okay, this guy's negative. Look back here. When I had 3 to the -2, the 3 had to go down to the denominator. 4 to the -2 can't be right, correct? Negatives aren't allowed. But it's already on the bottom, right? So it had to come up to the top. Everybody good? Got it? Okay, now I'm going to do another one. Don't write it down. You don't have to write this one down because we're going to do a ton of practice on these. -2 over 5 all to the -3. Think about it for a minute. You don't need to write it down. Just think. What would you do with it? All right, Jack, what do you think we should do with that?
Well, I think you times it like the normal one. So like -3 or -2 times -2 times -2. and then you times, 5 times 5, and then you flip it, and so your final answer is 75, make it 75 over 8.
Okay, 5 times 5 times 5 is not 75. It's 125, but I hear what you're saying. Okay, so you say my final answer will be 125 over negative 8.
No, negative 125 over 8.
Negative 125 over 8, which is the same as 125 over negative 8.
Yeah.
They're the same number, yeah? Okay, Jack's right with his final answer. He's wrong with his explanation, okay? As soon as I see a negative, what should I do to this fraction? Flip it. Becomes 5 over negative 2 to the 3. Now here's the mistake kids make. What isn't allowed to be negative? Exponents. What is allowed to be negative? Bases. So when I flip a fraction, what am I changing? The exponent only. The base stays negative. Can I make that any clearer? I don't think I can. And yet, every year, some kids will tell me that this answer has to be, this 2 has to be positive. Now, this 3 goes to everywhere, yes? So I have 5 to the 3rd over negative 2 to the 3rd, which is 125 over negative 8. Everybody cool? If you're lying, you're dying.
I don't want to die.
Then don't lie.
I'm not lying.
Are you cool?
Yeah.
You get this? Boy. All right. Okay, now we'll write a few down. Uh-oh. Exponent laws apply to numbers and variables.
What are we going to do?
I don't know. Of course we're going to use the laws. Which laws?
All of them. You want to don't know?
So, let's start with a nice, easy one. X, Y, all squared. Simplify that. Jack.
Well, what are X and Y?
Doesn't matter. Simplify that.
X times X.
Yes, X squared, Y squared, because the squared goes to everything. Everybody good? Everybody good? Okay. Here's the way it's going to go. We're going to do themes across here. Okay? All right. That was 1. That's the easy one. X squared, Y squared, squared. Okay, Jack.
X to the 4, Y to the 4.
X4, Y4. Why? Michael. You multiply over brackets, right? I shouldn't have used 2 and 2 and 2 because you can say it's add. Let's make it cubed. So now what is it?
6.
6 and 6 because you multiply over brackets. Everybody cool? Yeah? 100%? If you're lying, you're dying? Okay. Now, wait for it. 2x, y cubed. I'm worried, Jack, but I'm going to give you another shot.
So, I'm thinking that I don't want to answer now that I think about it.
Soft. Michael. 6? Michael. Why did you say 6? Shush for a sec. It is a 2. Is that how exponents work? But Michael, I'm asking you if that's how exponents work. Is 2 with an exponent of 3 the same as 2 times 3? No. So you're doing the right thing, but you're doing the wrong math, which I said somebody would do, didn't I? Every day we've been doing exponents. Somebody has done 4 squared. It's 8!
I just did that.
He just did it, yeah. Jack just did it, right? Okay. So you're right, Michael, because the 3 goes to the 2, yeah? But it's not 6. What is it? 8. 8 x cubed y cubed. Yeah? All right. And now finally, the last one in this theme, 2x squared y to the negative 2. No, not yet. No. I don't want to do that. I don't want to do that yet. I'll do that in a minute. Two, three, three. You're going to answer this time, Jack? You're going to make us all sit here and wait for you and then say, no. You've even stood up. We're at traditional school, apparently. Okay. You guys had to stand up to talk to your teachers at traditional school, right?
Yeah. Well, only grade 4 and 5 at elementary school, but
Okay.
Okay. So I'm thinking that, so it's 64.
Whoa, Big Poppy. 64? Where'd that come from?
My own number.
Sam, help a brother out.
8, x6, x6, and y.
Oh. Y to the 9. All right. Is everybody good with the first theme row?
I am now. Yeah.
Right? Because this base, this 2 is part of the base, the 3 has to apply to it. Is everybody Gouda? Great! All right, now let's move on to the second theme row, which I'm going to do in red. X squared y cubed over x y all squared. Remember, every math rule applies. You sure, Jack? Jack, I cannot be prouder of your confidence. I am glad you keep trying. You keep getting kicked in the teeth by math. You keep coming back for more. Go.
Okay. Okay, so it's like on the top it's x and x to the 1, so there's nothing, right? And then y to the second over x over y.
X. Oh, you're so close, Jack.
Square.
You're so close. You start out right, and then you just like, I'm cruising along. Yeah. Ooh, pretty flowers. You're so close. Why did I say all math rules apply? I didn't say all exponent rules apply. I said all math rules apply. Why did I say all math rules apply? Sam? X squared y to the 4th is correct. Why? How did you do it?
I did. So first the square into everything.
So this is what Sam did. I'm not saying it's right or wrong. He ended up with the right answer. This is what he did. He took this 2 to everything inside.
Yeah,
So he got x4, y6,
over
x squared, y squared, and then did x squared, y4. Right? Everybody cool? Now, Sam, although he got the right answer, technically did the question wrong, didn't he? Because what should he have done first if he follows the proper math rules? everything in the brackets first. So what he really could have done was tidied up the brackets and squared the answer. Everybody with me? Everybody good?
Yeah.
Okay, now, the third level.
Here we go. I'm gonna get this one.
Okay, Jack, I feel good for you, buddy. I'm feeling good for you, buddy. 2 x to the negative 4 y cubed over 3x to the 5th y squared all to the negative 2. Holy crap. I'm going to drink my tea.
Gosh darn it.
Scrooge McDuck. This is my favorite when I give a question like this, and the expressions on faces go from this to this.
I think I have an idea.
Tears. We knew you were going to go for it, Jack.
Thank you. Go my George. Negative 1x squared y.
Are you just giving me the answer?
Yeah.
Okay.
Give it up. Negative 1x squared y squared. Y is negative v squared. I know it's wrong, but I just went for it.
Why is it wrong? Like, look at it right now. What do you see in your answer that has to be wrong? What's never allowed?
The negative.
Negative 2. So you're wrong. You can't have a negative exponent. Now, no offense, Jack, because you guys haven't seen this before. You're not going to get it perfectly, right? Who else would like to try? It's kind of hard to do all at once. So what should you do? You can break it down, can't you? There's lots of ways to break this down.
I did this, but like I was stuck in the wrong part first. I didn't do the brackets first again.
That's okay.
I did, kind of. I flipped it.
So you flipped it. So you, Sam, went 3x5y2 over 2x 4y 3. When this positive went down here, what did he become? Or when this, so that would have to be negative 3. All to what exponent now? Positive 2, because I flipped. Now what? Now what? Okay. Can't do 3 over 2, but you can do these, right? So you're going to have 3 over 2. What's 5 minus 4? X to the 1. I'm going to write 1 because I'm not done. I'm allowed to write 1. What's 2? What do we do with 2 and 3?
Y negative 1.
No. Alicia. Right. So subtract it.
It's 5.
5, because it's 2 minus minus 3. Y to the 5th. And all of that is what? All of that is what? Still squared. Keep it rolling.
9x squared y 10 over 2.
4. Does everybody see it?
Yeah. You can't go further, right?
Nope, we're done. Now wait. A great many of you, or perhaps not a great many of you, some proportion of the classroom understands what we did there. Some proportion. Some of you, and I won't mention names, but I heard a few people going, no, and making sad faces. There's another way to look at this. that breaks it down in another way. I'm going to do that right now. Zach. Jack.
Why is the 3 negative? Like,
Because it moved from up there to down there.
When you flip it, the sign changes.
The sign has to change when you flip it.
Because if you change the negative, why would you change the positive?
Oh, I screwed up! I'm a doughhead. I only remember to change one of them. Now, wait. I'm super happy this happened. Okay, I'm super happy this happened. Because, here's why. How easily did I let this happen?
Super.
Right? It was real easy. There's a lot of steps. It was real easy, right? So I was getting a little too confident, yeah? Now watch. I'm going to show you another way to do this. Watch this. I have 2 over 3 to what power? No. Negative 2. I have x to the negative 4 over x to the 5th. To what power? Negative 2. I have y to the 3rd over y squared. To what power? Negative 2. Now, I have choices. This negative 2 goes where? With 2/3. Everywhere. So I'm going to have 2 to the negative 2 over 3 to the negative 2, correct? Are negatives allowed? No. So that becomes 3 to the positive 2 over 2 to the positive 2, which becomes 9 over 4. Cool? Is everyone cool there? Yeah? 9 over 4. Everybody good? The negative 2 goes everywhere, Jack. We know that law. Right? So 2 to the negative 2. But negative 2 can't exist, so it goes to the denominator. Negative 2 can't exist, so it comes up to the numerator. Cool? All right, now let's look here. Do I have a choice? Can I do the brackets first?
No.
I can. What's negative 4 minus 5? Negative 9. So this is x to the negative 9 to what power? Negative 2. What's negative 2 times negative 9?
Negative 18.
No. Positive 18. Where do positives go? Numerator or denominator? Numerator. So I have x to the positive 18. Yes? What's 3 minus 2? 1. So that's y to the 1 to what power? What is it? Y to the negative 2. Where do negatives go? What if they're already on the bottom? Then they go up. They move. So y, and what do negatives happen once they move? Become positive. That's the right answer. It wasn't on the bottom. This was y to the 1 times y to the negative 2, so it's y to the negative 2. No, it's only on the bottom when we move it to bottom. This is technically y over 1 squared. Now, here's the thing, because a great many of you have been going along. Nope, I got no problem with this, Myers. I got it. Easy peasy. Exponent laws 1, 2, 3, 4, 5, 6, 7, 8. Got it. Kicking its ass. Yep, it's all mine. I'm not even going to ask you if you can show me how to do nothing, because it's all that easy. Now, if it was that easy, what's the only thing that got added today? Negative exponents can't exist, yeah? I added one fact, and now all of a sudden, yeah, I'm doing her.
You have like flip and like, this is my bag.
But, Sam, what has really happened? One new fact. The problem is, you got to remember all 10 previous ones, don't you? Yeah. Everybody cool? Now listen. I recommend. Well, yeah, they do, Sam. I just only gave you one step at a time. Yeah. But they're all the steps. That's kind of like saying, all right, I can walk. 2 steps, brother. So now I'm fit to walk across Canada now, right?
Yeah.
No.
Well, you can drive.
What, Derek? Not on Friday. Friday's test has nothing to do with this exponent law.
We have a test tomorrow? I thought it was a quiz.
Yeah, it's a quiz. He calls it a test. All right, is everybody good? All right, now, should we do a couple more that require... I have found in my experience that trying to write it down and do the math is too much for you guys when you're learning this. So nobody write, okay? Just look, think, talk to your neighbor, and get ready to go. Is everybody cool? I'm going to write the question up here. It's going to be hard, yeah? 3x to the 6th, y to the negative 4, z squared over 4x to the negative 2, y to the 6th, z to the 4th, all to the negative 3. Now stop and think about how you want to do this. I have shown you 3 ways to do it. You stop and think. Who would like to offer, after they've thought about it for a moment, their first step? Because whatever they do, I'm going to follow them through. You ready to try, Sam? What would you do first?
I would split it up.
So, Sam says he's going to split it up like that. Is everybody happy with that?
Yes.
Okay. That's not an exponent law, is it? That's just math. We can do that, right? Okay. Now, what is the next exponent law you want to put here?
I want to do, like, start with the first column.
Okay. So you're starting with 3/4.
In brackets.
Okay.
Well, you can also do that. Yeah, but, so 3/4 to negative 3.
So you want to have, you're going to bring the negative 3 here. Now, what exponent law applies when you have a fractional base that is different bases with an exponent? Where does that exponent go, according to our laws? Everywhere, to both, right? So this becomes 3 to the negative 3 over 4 to the negative 3. Now, what is the only new law you learned today? Negative exponents can't exist. So this guy has to go down and become positive, and this guy has to go up and become positive, which gets me to my last step, which is, I'm out of room here, 64 over 27. Cool?
Yes.
All right. So that Sam is going this way. Now, what's the next step? I'll change to blue.
It's the,
So keep walking us through this, Sam.
x6 over x negative 3, all to the negative 3.
Okay.
And then
He has options here, doesn't he? Because now they're the same base. So what can he do? He could subtract now and then deal with this. Or he could apply this to everything and then deal with the subtraction. So what would you do now, Sam? Because I said I'd follow yours all the way through. I just want people who are not on your page, if they're thinking of a different path, I want them to know that it's valid. So what would you do now?
okay, so like you could do the 6 minus 2 and then
It's not 6 minus 2, though.
it's
It's 6 minus minus 2, which is 8. So this is x to the 8 to the negative 3, which is x to the negative 24. Where do negatives go? So where does it go? With the 64 or the 27? With the 27. And what happens to the exponent? Positive. Everybody cool? Okay, what happens with y? It was y to the negative 4 over y to the 6th, all to the negative 3. So that's y to the negative 10 to what power? Which is with 64 or 27? 64. And the last one? Z. Is that readable? Barely. Z to what? Z squared, Z4, all to the negative 3. Z to the negative 2 to the negative 3. Positive 6, which goes with the 64.
I followed along that time.
Is everybody good?
Yes.
Could you have done this another way?
Yes.
Could you have done this? 4x squared, y to the negative 6, z to the negative 4 over 3x to the negative 6, y to the 4th, z to the negative 2, all to the positive 3. Yes, because the negative flipped everything in here, right? Which changes the exponents. Now, well, let's check. 4 cubed is 64. 3 cubed is 27. Are we okay? Yep. 2 minus 6 is 8, right? 2 minus 6 is 8 times 3 is what? 24. Uh-oh. What happened? Well, x is positive 24, so wouldn't it go up top? But didn't x need to be on the bottom? So what does this tell us? Okay, what does this tell us? How many steps did this take? Like, honestly, how many steps did this take? How many laws did we need to know? All of them, right? If you try to hold them in your head, can you screw it up? Okay? Now, I know where I've made my mistake. Right? I know where I've made my mistake because I'm trying to talk, write, and explain at the same time. I know what I did wrong. And I'm hoping one of you will spot it. When I flip this fraction, why am I flipping it? What am I trying to get rid of? Which negative exponent when I flip it? Just the 3. What did I do while I was writing and talking accidentally to every other exponent? Flipping it only affects this guy, doesn't it? So what did I do? Should I have changed all these? No, and I did because I was talking and writing and not paying attention. Okay? So, the only thing that changes is our outside exponent, which is why I prefer this method for you guys. I prefer you to split it into chunks. I don't want you to try and do it all at once because of what I just did. Did you see how easy it was for me to do that? Right? Now, would I have caught myself? Probably, because if I was doing this myself, I wouldn't have been trying to talk and write. Picking up what I'm putting down?
Yeah.
Okay. So, what do I got to remember? The flipping only takes care of the one I'm flipping. Okay? Yes.
So in that method,
So this should have stayed negative. This should have stayed positive. This should have stayed positive. This should have stayed negative. This should have stayed positive. This should have stayed positive. Now let's check. 64 and 27 are okay. Negative 2 minus 6 is negative 8, right? Negative 8 times 3 is negative 24. X to the 24th. 6 minus minus 4 is 6 to the 10th, right? 10 times 3 is 30. Y to the 30 stays up top. 4 minus 2 is 2. 2 to the 3rd is 6. Z to the 6th, it stays up top. Is everybody good?
Yes.
Okay. Your homework is this, just the next page. Just that page. I think there's 11 questions on it, or 12? 12. That's your homework. Okay, now listen. Tomorrow, how many of you are going to the buyout game? Put your hands up. You're not in trouble. Just put your hand up. One sec, Howie. That's fine. Yes. Today is day 2. So we end with C. Okay? All right, if you're not going to be here tomorrow, we're going to go over this sheet. And we're going to write a quiz. This sheet I will post on YouTube so you can mark your own work. Okay? Everybody with me? Yeah? All right. And I will post what we just did today on YouTube.